Hi, I'm Hafeez again, and I'm going to take you through to last area of the decision making, which is the decision making under risk or uncertainty. In this topic, we are going to discuss a couple of areas, very tiny areas of the syllabus. One is decision tree analysis, and second will be sensitivity analysis. Okay, so first of all, decision tree analysis. Decision tree is a diagram actually which we draw. First of all, it's a diagram analysis which shows several possible courses of actions and all possible courses of outcome. Okay, so it's diagram which shows multiple decisions and multiple outcomes. That, for example, I'm standing in here and I'm thinking what to do. If I invest in this company, what will happen? Or if I invest in that company, what will happen? If I invest here and it's affected by a number of other factors, for example, weather. If I invest in this industry, what would be the possible effects of weather on this industry? And if I invest in that company, what would be possible effects of weather on this company? If the weather goes very good, what would be possible result? If the weather is moderate, what would be possible effect on profits? And what if the weather is worse? What would be possible effects on profits? So in this diagram analysis, what we look at multiple situations, okay, a number of decisions under consideration and a number of outcomes at the same time. And then by analyzing all of them, okay, whichever generates best results for us, we go with that one. Okay, so it's a diagram analysis showing several possible actions and all possible outcomes. Okay, there are some symbols we use in this diagram, okay, which I'm explaining here. A decision is represented by a square. Okay, some people call it decision point, that I am standing in here, so this point will become a square. Okay, and then whether I go this way or that way, something will occur, and that something which is going to occur is called as outcome. So outcome point is represented by a circle. Okay, and decisions and outcomes are connected by the lines or connectors, okay, straight lines or connectors. So in the exam questions on decision tree, there are typically two stages involved. One is to draw or construct the decision tree, and second is analyze or calculate decision tree values. Okay, right? One is develop the decision tree, construct or draw the decision tree, which is generally from left hand side to right hand side. But it's not a hard and fast rule. People can do from right hand side to left hand side as well, or they can draw a proper tree coming from bottom to top, okay, and the branches all over. But no, best is to follow the ACCA standardization. That decision tree will be drawn from left hand side like we write English, and then it goes towards the right hand side. Okay, and second will be the calculations involved in decision tree. Now good thing is we have learned some calculations already which we will be using in this decision tree analysis as well, and that's the idea of expected value. Remember expected value? I can write down the formula for you again as well, which is the sigma px or xp. Okay, sigma or sum of px. Exactly the same idea. And remember, what was the decision rule for expected values? Choose the highest expected value. Choose the highest expected value. Exactly the same principle will be applied. Let's have a look at an example. We will draw and then we will do calculations as well. Example, 7 Trees Limited. The following information relates to 7 Trees Limited, a company which is considering whether to develop and market a product. Here are the probabilities. Development. By the way, what comes first? Developing comes first or marketing comes first? Of course, I agree with you, development comes first. So I'm standing in here and I'm thinking, should I develop the product or should I not develop the product? Okay, right? In both ways. If I develop the product, my development may be successful with 0.75 or 75% chances of success. And if I develop, I may be unsuccessful with 0.25 or 25% chances of success. So idea is, if I do develop the product, I may be successful, I may not be successful, the future will tell, the time will tell, okay? So here is the starting point of this decision tree, okay, which is a square. Okay, which is a starting point, decision point, develop or not to develop. Now please keep in mind, labeling is very, very important in any diagrams, whether it is linear programming graph, CVP or profit volume graph, or decision tree diagram. Labeling is as important or even more important than the diagram itself, okay? So keep in mind. Here is one side, development may be successful or if we are unlucky, development may fail. Sorry, let me just do it again. I just need a little bit more space. Okay, so I will start it from here. Okay. Because I need to take it both ways, so I need a little bit more space. Now here is, I'm thinking, should I develop or should I not develop? So here is the development. Then let's say I go for development. If I go for development, okay, one of the two things may occur, okay? 0.75 or 75% chances that development may be successful, okay, and at the same time 0.25 or 25% chances that it may not be successful. It may be failure. One of the two things may happen, okay? What if I do not develop the product? What if I decide not to develop the product? What do you think, what will happen? Well, nothing will happen, okay? Probably I'll go to sleep, okay? Or I will start playing some tennis if I don't want to develop the product. But nothing will happen. So it is like a dead end, okay? I need to think about doing something. It's being lazy not to develop. If I don't want to develop, fair enough, I can do something else, okay? But which is not part of this. At the moment we are comparing, should we develop the product or should we not develop the product, okay? If results are better in development, we will develop. If results are better in no development, we will not develop. Meaning to say is, for example, we analyze the whole thing. I'm just saying, we analyze the whole thing and we end up with a loss of something if we develop the product. Then it's better not to incur a loss and do not develop. So that will give us the idea whether developing is financially viable for the company or no development is financially viable for the company. Let's proceed to the example. Estimated development costs would be $180,000. If we develop, estimated development costs will be $180,000, and if we don't develop, of course there is no cost because we don't want to do anything. Afterwards, if successful, it's talking about development. If development was successful, then the product will be marketed with the following probabilities. Now we will market the product because development, for example, was successful. In that case, one of the three things may occur: that our development may be very successful, moderately successful, or failure. And in that case, we will end up with these profits. Okay, 540, 100, or $400,000 loss. One of the three things will occur if we market the product. Okay, so it comes on this side. Because remember, if the development fails, then again another dead end. We can't go any further, full stop. But if development is successful, then only we can do the marketing. So this circle represents our marketing results. That if we market the product, one of the three things may occur. One of the three things. One is, it is very successful. It is moderately successful. And if we are unlucky, our marketing may fail as well. People may not be interested in our product. Okay, so any hopes and any risks. So probability is given 0.4, 0.3 and 0.3, and the profit and loss values are given as well: 540, 100, and a loss of 400,000. This labeling is very, very important. I mean, all these words and any probabilities and any dollars or pound values, okay? Without labels, you will not get full marks. So please keep in mind, okay? You don't need to write down exactly the same words. Numbers will remain the same. Words, you can choose any of your choice, long as it makes sense and it has some meaning, okay? It tells me what is the meaning of this branch. Okay, the last part is the above profits or losses figures include the effect of the development cost, meaning this development cost, which was $180,000, that has already been adjusted into these values, okay, because it says clearly the above profit and loss figures include the effect, mean this 180 has already been deducted from the total profit or loss. If examiner was saying the above figures exclude the effect of the development cost, then we had to further subtract $180,000. But we wanted to keep questions slightly straightforward so that you are not involved in basic calculations, you are focusing on the decision tree. Okay, so there is no actually adjustment required in relationship to 180,000, 540, 100,000 and loss of 400,000. That's the final net profits from this project. Okay. Right, this is a complete decision tree you can see here on the screen. Okay. Okay, this is a complete decision tree. Now the next phase is evaluation or analysis of this decision tree. Okay, let's do the evaluation, or you can call it computations of the decision tree. Okay, there are two ways to do it, completely your choice. Okay, for me both methods are the same, end up with the same answers, completely your choice, whichever is suitable for you. Okay. Some people do it in this way, that they work backwards from here to here, then here to here, and then here to here. Meaning to say is 540,000 times by 0.4, they get one value here. Then 100 times 0.3, they get another value here. Then 400,000 times 0.3, they get one value there. Okay. Then they do the total. This total value multiplied by 0.75, it comes in here. And then if it fails, 0.25 times 180,000, it comes in here. And then this total is dragged up in there. Okay, working backwards. Okay, this is one approach. Second approach is reading all lines and showing calculations separately. So completely your choice. For me, both are the same, whichever is suitable for you. Let's read all lines here. First of all, if I'm looking at no development, if we don't want to develop the product, what would be expected value? Okay, so please remember, calculation or computation of decision tree will be based upon expected value, and if you don't mind me repeating things many times, this was the formula of the expected value, sigma px. Okay, more we will remind ourselves, better chances of remembering. So calculations are based upon expected value formula. If we do not develop the product, can I say expected value will be 0? No profit, no loss, no probabilities, nothing. Okay, what if we develop the product? Here is the second branch of the decision tree. What if we did decide to develop the product? This is something that may occur. Okay, that we develop the product, we spent 180,000. Simple things first, shorter part of the decision tree. And we developed the product and we failed. 25% chances we may fail. Here is the expected value if we failed. Okay, because we spent the money already, 180,000 times 0.25, and here is the expected value. $45,000, which is negative because it's a loss. So if we develop, we may fail, and in that case we may end up with a loss of 45,000. But what if we don't fail, we become successful in development? If we are successful in development, then one of the three things may occur. Okay, we may have very successful marketing, we may have moderately successful marketing, and we may have a failed marketing. Okay, let's pick up the numbers. If our marketing is successful, we will make a profit of 540, I think. Moderately successful, profit of 100,000, and failure, there is a loss of 400,000. Now what you need to do is look at each branch of decision tree. I copied and pasted the profits and losses. Now what you need to do is this. Please look at one by one. Okay, first of all, look at the first, which is 540,000. How is it? It's like this. We developed, we were successful, and our marketing was very successful. Okay, like the complete, right from the decision to its destination or end. We developed, our development was successful, we marketed, and marketing was very successful, and then we generated $540,000 of profit. In this whole branch, can you see there are two probabilities coming along, 0.4 and 0.75. These are to be multiplied here, times 0.4 times 0.75. Exactly the same thing with the second one. Please look at this second one. That we developed, we were successful in development, but we were moderately successful in the marketing. And again, there are two probabilities in this branch, 0.75 for the successful development and 0.3 for the moderate marketing. So times 0.3 and times 0.75. Don't add them, multiply them. And same thing, 0.3 and times 0.75. And here are the expected values of successful or unsuccessful marketing. Okay, let's do it 540,000 into 0.4 into 0.75, which gives us 162,000. Then 100,000 into 0.3 into 0.75, which is 22,500. And lastly, $400,000 loss into 0.3 into 0.75, which is negative 90,000. Now here is the sigma. If we develop the product, can you see there are some risks as well as hopes? There are risks as well as some hopes as well. And that's the meaning of weighted average or summation. Let's add them together. 45 is negative plus 162,000 plus 22,500 and minus 90,000, and it comes to 49,500. Okay, if we develop the product, expected value of the profits will be 49,500, and if we do not develop the product, expected value will be 0. So do you want a profit of 0 or do you want a profit of 49,500? It doesn't mean this 49.5 profit will actually occur. This only tells us some expectation that a profit may occur if we develop the product. Okay, actual profits will remain the same, 540 or 100 or minus 400,000, whatever the outcome, but indication that there are greater hopes as compared to the lower risks. Hopes are more than the risks in this scenario. Okay, and based upon the higher expected value, we should develop the product. So here is the decision, one line decision we can tell the examiner. Okay, as expected value of developing the product is higher, the company should go ahead with development. Okay, as the expected value of developing of the product is higher than that of non-development, the company Seven Trees Limited should go ahead with the development. Okay, so whichever way of calculation you want to follow in exams, they are very much happy. Separate calculations or right on the face of decision tree, you can work backwards as well. In both ways you will get to the same answer. Okay, now let's have a look at the last area of uncertainty, which is another model or tool we apply to evaluate decisions, which is called as sensitivity analysis. Okay, sensitivity analysis is a method of risk or uncertainty in which the effect on the expected outcomes of the change in values of key variables or key factors is tested. Meaning is this: we compare one variable with another, that if one variable changes, how much is the impact on the other variable, and if impact is too much, it makes it too risky. It makes it too risky that a slight change in one factor may occur and another factor may be changed that much that our decision may not be viable anymore. Okay, so for example, when new products are launched, okay, at the time of new products, we are expecting to launch the product at a selling price, and the hope is that our selling price will be appreciated by the customers. But what if another competitor jumps in the market and we have to drop our price? Question arises that how much price drop may occur? What if the price is dropped too much and that price doesn't even cover the full cost? It means we will end up selling the product at a loss. So the question is that is the product risky, or is the product less risky, or is the product more risky? Okay, that a small change in selling price may end up in a loss situation. So sensitivity analysis is simply comparing two variables, okay, and we test what kind of factors make up the total variable, and then from that variable we keep on looking at individual changes. Idea is very simple, okay. I mean, in theory it's slightly complicated, but idea is very simple. If I just give you a little example, you will understand it quite well. For example, we know profit. You know, profit is the difference between sales and costs, very different type of costs, and we end up with profit. Now this profit is something, a key variable, okay. This profit is called as key variable, meaning is if any product or any decision ends up with a profit, we go ahead with that decision. But if any decision while evaluating we end up in a loss, then we would not even go with that decision. We will think about doing something else, okay. So this profit is the key variable. What we do is we compare this profit with any variables which actually make up this profit. For example, can we calculate profit without sales? No, sales will become part of profit calculation. So we will compare profit with sales, okay, that how much sales may drop by and our profit may be converted into a loss, okay. Or cost. We know that without cost there is no profit. Sales minus cost equals to profit. And we are trying to see how much of cost can increase by and we will still be profitable, or how much cost can increase by and we will end up in a loss situation. So this comparison is called as sensitivity analysis, okay. Greater the sensitivity, lower the risk, okay. Idea is, I will tell you in terms of percentages rather than using the words. Sometimes words confuse us, but with the numbers we get the better understanding. So let's have a look at an example. SPY Limited. Requirement: analyze the sensitivity of the decision to changes in the above costs or selling price of A plus, which I think it looks like a product. A company currently produces and sells product A at a selling price of $2,150 per unit. So at the moment, current price of product A is 2150. Management have decided to further process product A to product A plus. The costs of further processing will be as follows. So if we process A into A plus, these are further processing costs, in total 760. The selling price of A plus will be $3,100 after further processing. The above additional costs are estimates only and are subject to change. I mean, suppliers can change the price, workers may start demanding more money, more labor rate, and variable overheads like electricity and power. Companies keep on changing the tariffs, etc. The purchasing manager has indicated that the market price of the materials can be quite volatile, which can be fluctuating, and sometimes these fluctuations may not be in our interest. Price may go up quite, okay, right. Now there are two things in this question, okay. One is further processing decision and second is sensitivity analysis, okay. So let's do them one by one. First of all, let's do the further processing. Okay. Right, at the moment, current selling price of A I think it is 2,150. Is that okay? Current selling price is 2,150. And if we convert into A plus will sell for 3,100. Okay. product A plus selling price will be $3,100. So here is the incremental or additional revenue from A plus. Okay, which is 3,100 minus 2,150, which is 950. That's the incremental revenue if we convert A to A plus, but this is subject to additional costs. So let's deduct incremental or additional costs, which are 670 and 90. So direct materials, direct labor and variable overheads in short. 670 and 90, and in total it is 760. So if we convert A into A plus, we will generate additional revenue of $950 after spending cost of $760, and I think it would still generate an incremental profit after further processing. This will be the additional profit from A plus. 950 minus 760, which is $190 of additional profit. So on its own further processing, it looks viable, financially viable to process the product A into A plus. Okay, now here is the second part of this, which is sensitivity analysis. Sensitivity analysis. Now, first of all, please remember this formula for the sensitivity analysis before I start doing a couple of things. In sensitivity analysis, first of all, we always take the final variable or key variable, which is almost profit. Okay, so profit value is always taken as a numerator divided by any variable used for profit. Meaning, what factors did we use for profit? Meaning, we used selling price, we used direct material cost, we used labor cost, and we used variable overheads, and that factors have generated the profit. Okay, so let's compare the sensitivity of profit to the selling price of A plus. $190, and selling price is, I think, 3,100, and if you multiply the answer by 100 just to get answer expressed as a percentage, we call it sensitivity analysis. Okay, let me write down, then I will explain. It says 6.1% approximately. Okay, it is approximation, maybe 1 decimal more or less. Okay, 6.1%. Now here is the meaning of this. Meaning is that if the selling price, which we think at the moment is 3,100, what if the selling price decreases by 6.1%? At the moment, profit is $190, and if the price drops by 6.1%, this incremental profit will go down to 0. There will be no more profit left if the selling price of A plus drops by 6.1%. And if the selling price of product A plus drops by 6.2% or more, this incremental profit of 190 will be converted into a loss. Okay, so the question is, sales or marketing people or top management needs to think about that, is it too risky or not? Okay, what if any other things happen? So they look around, do the research, look at the past experience as well, that whenever they launch the product, how the trends go. Okay, do they have to drop the price or do they not have to drop the price? So of course, If their product is very unique and they are very much confident they wouldn't need to decrease the price, they can go ahead. But if their product is not that unique and there are other competitors as well, okay, they may end up dropping the price. Maximum price drop they can afford is 6.1%. And if the chances are price drop may be higher than 6.1%, they should not do the further processing. Okay, let's do another one, which is direct materials, and I think that will be sufficient. Okay, let's compare the sensitivity of this product in relationship to direct materials. So $190 is the profit divided by direct materials 600. First of all, let's get the percentage and then we will interpret the results, which comes to approximately 31.67 or 7%, meaning to say if the suppliers or any other inflation or any other oil and petroleum effects or any other reason, shipment charges, if the price or cost of direct materials increases by 31.7% in the market, the profit of $190 will go down to zero. And if the price of material increases by more than 31.7%, this product will not remain financially viable. Okay, and likewise you can compare it with the labor cost as well, compare it with the variable overheads as well. So comparison is like this. Generally idea is you can see a smaller percentage 6.1%, and here you can see a greater percentage 31.7%. so smaller percentage reflects greater risk, mean only 6% change will make it this product unviable, and 31.7% change will make this product unviable. So here is a higher risk we can see, here is the lower risk we can see. Okay, so that's how they look into the situations, whether it's worth going ahead with the further processing or other way around. Okay, so that was all about your decision making under uncertainty. Okay, as usual, please revise your study material, textbook and the session notes, and then watch the video and try to do the same examples again. Okay, and then additional questions from the revision kit, right? And then any problems, of course, you can always come back to us about any questions. Okay, all the very best, take care and goodbye.